Hi, this is Jessica Dunn, and we're going to discuss our financial calculators. I like to use the Texas Instruments BA2 Plus. These are available on a large number of websites, including Amazon and Walmart. They're also available in-store purchase at the school library or at the school bookstore, as well as Walmart. They're about $25. This is the professional edition, so it's slightly more. However, that is completely unnecessary. So with a financial calculator, the primary requirement is that you have these available inputs on the calculator screen. So you need to be able to find a place where it has N, IY, PV, PMT, FV. If it does not have those buttons, then it is likely not a financial calculator and will not have the built-in functions to allow you to quickly calculate the answers to the problems. So let's just jump right in with the BA2 Plus. The BA2 Plus, notice that there are basically two buttons for every button. So for example, the compute button, which is circled, CPT, is also the quit button. Right above compute, it says quit. So to access the words above the keys, so like the up arrow is also delete. To access those words, you have to use the second button, that dark gray button, to access those words above the keys. So every button has two functions. The primary buttons that we're going to be using in this class are N. N is the number of periods. IY, that's the interest rate per period, the periodic interest rate. PV stands for present value. PMT is used for payment. And FV is for future value. CPT is compute. So let's first do some housekeeping with your calculator, and this is things that you should only have to do once. We need to make sure that your calculator is formatted correctly. And so what I mean by that is we want you to have a floating rate decimal button or decimal display in your display screen. Without that, you may get rounded answers that aren't correct. So to make sure that your calculator is formatted correctly, you need to push the second button, which is the dark gray button, and the format button, which is the decimal located on the bottom row of your calculator. We need to set the decimal equal to 9, and that will give you a... So I have a BA2 Plus emulator that I can use to work through problems alongside you, so that way you can see the exact keystrokes. So I'm going to be pushing the second button and format, and I want my decimal to be equal to 9. Notice that mine already is, but if it wasn't, I could just type in 9. Notice that there is not an equal sign now, so that means it's not saved. The top of the center of the screen prompts you and it tells you what buttons are available within this menu. So if we push the enter button, now it's saved. We see that equal sign is solid. You can scroll through this and see what other information is available, but the primary thing is that we want your decimals equal to 9 so that you get that floating rate decimal. The other thing that I want you to check is to make sure that your calculator is in end mode, END, end mode. There are some instances where we will have it in begin, but primarily our calculators will be in end mode. To check this, well, it will be obvious if your calculator isn't in mode. It will look like this, and I'll show you how to get it out in just a second. Okay, so if your calculator looks like this, notice it has that BGN, begin, in the upper right-hand corner. We don't want it to look that way. So if yours looks that way, then you need to push the second button and begin, which is also the payment button. Notice that your calculator prompts you at the top center of the screen and it says, if you don't like this, push the set button. The set button is also the enter button. So second, set. Now we can just press clear. And now it's in end mode. So that is the nice thing about the BA2 Plus. You do have the option of using a graphing calculator. They do have the financial calculator options within them. To access that, you would go to Apps, Finance TVM Solver. Now the problem with the graphing calculator is that it doesn't tell you on the main screen whether or not your calculator is in begin mode. You have to scroll down to the bottom of your TVM solver and make sure that the cursor is on the end. So the idea of time value of money is that money is not static. The value of a dollar is continually changing. So if you had $430 in 1920, you could have bought a 2.5 carat princess cut diamond ring and dinner out every night for a year. Today, $430 would not even pay for a 2/10 of a carat round cut diamond ring. It wouldn't cover the tax. So this is just to illustrate that a dollar today and a dollar yesterday aren't the same thing. We have increasing prices, mostly due to inflation. So here's another example of that. This is an ad from a Sears and Roebuck catalog in 1940. And you can see that this home, it was roughly 1,900 square feet, was selling for $1,953. It was a kit house. So certainly you couldn't buy this home or the materials to buy this home, to build this home, for $1,953 today. So in finance, time value of money is a very important concept because when you're evaluating projects in a corporate setting, most benefits and costs don't occur at the same point in time. So typically you're going to have an expense, an outlay of funds that is followed by a series of benefits. And so we need to bring those costs and benefits to the same point in time to make meaningful comparisons. So if we wanted to make a simple comparison, let's say you had the option of taking $100,000 today, or you could choose to have $200,000 in 10 years. Which would you pick? There's not a right or a wrong answer. It depends on a lot of things. It depends upon your consumption today, your needs today, what's your current income, what's your opportunity cost. So the problem is that the costs and benefits don't occur at the same period of time to make a nice, clean comparison. So if we're looking at time value of money, the primary thing we want to do is to bring all the cash flows to one point in time. Usually that involves finding either the present value or the future value. So let's look at a company. They have the opportunity to spend $15,000 today on an investment that will yield $17,000 over the next 5 years. And the cash flows are spread out so that in year 1 they have a $3,000 cash flow, year 2 $5,000, year 3 $4,000, year 4 $3,000, and year 5 $2,000 for a sum of $17,000. So they're spending $15,000 today to earn $17,000 over the next 5 years. Is this a wise investment? Well, it sounds okay, but to get a true answer, we would need to find those cash flows and bring them to the same point in time. So we would need to bring all of those incremental cash flows over the 5 years back to time period 0. We would discount them back to time period 0 and compare those benefits to that cost of $15,000 to see if we're getting an adequate rate of return. So the first thing that we always do when we're evaluating time value of money decisions is we always put our cash flows on a timeline. So here you can see that we have time as denoted with 0 through 5. Here that's years. It could be months or weeks or days, but in this instance we're using years. Time period 0 is today. Time period 1 is 1 year from today. Time period 2 is 2 years from today, and so on. Above that, you can see that we have cash flows. So our costs are denoted with a negative number. So we have a negative $15,000. That is cash that has left our pocket. So when we're looking at timeline, it helps to think of your cash flows as inflows and outflows. Money coming into your pocket or leaving your pocket. So in this instance, we would be spending $15,000 to purchase an investment that will yield us $17,000. So that $15,000 purchase is a negative cash flow. It's a cash outflow. So we need to put a negative sign with that. The remaining cash flows are cash inflows. We would receive that as a benefit of purchasing this investment. And so they are positive. This allows us to see the cash flows and to make sure that we're inputting them into our financial calculators correctly. So the options that we have, we could take all of those cash flows and throw them into the future and get the future value. Or we could bring them back to today's dollars and get the present value. And they're both fine options. You'll get the same answer with either. The first option, however, is compounding, is taking cash flows and moving them forward to a point in time. That is called compounding. Compounding is the idea that if you were to invest money today into, let's say, a savings account, you invest a dollar amount into that account today. Next month, you're going to receive an interest payment on that money. So that interest payment, if you don't spend it, it's added to your savings account balance. So it becomes a part of the principal. And so next month, when you receive interest, you're going to receive interest on your new principal balance, which includes last month's interest. So it's the idea that your interest starts earning interest. Discounting is the inverse of compounding. So future value, as we said, it is found by using compound interest. And compound interest is the interest that is earned on a deposit that becomes part of the principal at the end of the period. And principal is the base amount of money from which the interest is paid. So let's just do a little example here to illustrate the formula derivation. So if Fred puts $100 into a savings account and that account pays 8% interest that's compounded annually, meaning that it pays interest once per year, how much would he have at the end of the first year? So he had $100 and he's going to earn 8% on that $100. Excuse me, it's a 100, not a 1,000. And so that gives him $108 at the end of the first year. So the future value at the end of year one is equal to the $100 he initially deposited plus the interest he earned on that deposit. So he would have $108. Now, if you don't enjoy formula discussions, you can tone this out a little bit. You need to get the general gist of it, but I'm not going to ask you to do this on an exam. So let's see what would happen if he left the money in for a second year. So how much would he have at the end of a second year if he was earning 8% on his investments? So he initially deposited $100, which grew to $108. So he has $108 into his account. And now he's earning 8% on that 108. That gives him $116.64. But we could really break this down more because we know that $108 is equal to 100 plus 8% times 100. So let's do a little bit of reconfiguration here. Let's first notice, here I'm going to be reconfiguring this equation. Let's first notice that we could factor out the 108. So we could pull that out, and then we'd have 108 times 1 plus 8%. We could have done the same thing up here. We could have said, factored out the 100, and it would have been 100 times 1 plus 8%. And that still equals $108. this still equals $116.64. We just factored out the principal component. But when we look at this, we see that 108 is actually equal to 100 times 1 plus 8%. So let's substitute that in for our 108 in the bottom calculations. So all I did here was substitute in this 100 times 1 plus 8% in for this 108 because they're equal to one another. So now, looking at this, we could say 100 and combine like terms, 1 plus 8% times 1 plus 8%, so that's 1 plus 8% squared, is equal to 116.64. It's just different ways of writing the same equation. So with that, now it's starting to make a little bit more sense. When we read this problem up here, we actually see some of those numbers in the equation. We see that the amount we'll have at the end of the second year is equal to the amount we initially deposited, that $100, times 1 plus our interest rate, our 8%, raised to the number of years. So if we put that into a generic equation, it would look like this. The future value is equal to the present value, the amount we initially deposited, times 1 plus our interest rate, our periodic rate, raised to the number of periods. So FV was future value. PV is present value. N is the number of periods. And R, sometimes seen as I, on your calculator it's going to be IY, is the rate. So the future value is equal to the amount initially deposited times 1 plus the rate raised to the number of periods. So in that Fred example, our future value is equal to the 100 we initially deposited times 1 plus the 8% we were earning raised to the number of years to give us 116.64. Now let's go back and look at that Fred example again. Notice in the first year we earned $108. So we have $8 in interest that we earned. The second year, we didn't earn $8 because then we would have had $116. Instead, we had $116.64. In the second year, we earned $8.64. Where did that extra 64 cents come from? That is the interest that was earned on that initial interest payment of $8. So that $8 earned us an extra 64 cents. And that's the idea of compounding, is that your interest that you earned is added to your principal and it also starts generating interest. And so this has a snowball effect. In the beginning it's quite small, but as your interest payments grow, the compounding effects are tremendous and it causes your money to grow at a very rapid rate. So let's do an example. Jane puts $800 into a savings account. That account pays 6% interest compounded annually, so the interest is added to the principal once per year. How much money will she have in her account at the end of 5 years? So remember, we have this equation. Future value is equal to present value times 1 plus the rate raised to the number of years. So if we put this on a timeline, she put money into an account today and she left it there for 5 years. She wants to know how much money she'll have in 5 years. So that's a question mark. How much money will she have if she puts $800 into an account today? Now to her, that's a cash outflow. Even though it's her savings account, it's still she pulled money out of her pocket and put it into a savings account that she's not going to touch. So we'll put as a negative for the timeline. And looking at this timeline, you may be thinking, why am I doing this? Timelines are so unnecessary. I see this in my head. But I promise you, as these problems get more and more difficult, the timeline will become more of a necessity. So it's better to get in practice today. So if we're putting this into an equation, how much did she initially deposit? That's the present value, $800, times 1 plus what interest rate is she earning on that account? 6% raised to 5 years. So $800 times 1 plus 6% raised to the 5th power. Let's work that on our financial calculators. So we first start with what's inside the parentheses, the 1 plus 6%, 1.06. We need to raise that to the 5th power. To do that, we need to use the y to the x button, and then 5 equals 1.338, and multiply that by 800. So just make sure you follow your order of operations. You get $1,070.58. That is how much Jane will have at the end of the 5th year, earning 6% on her investments if she left it alone for 5 years. So right now you may be thinking, why did I buy a financial calculator if we're not going to use one? We are. I just wanted to first explain to you the formula. I don't expect you to use the formulas. In fact, I urge you to not use the formulas simply because as these problems become more complicated, the formulas are going to become much more complicated and will take you way too long for your exams. So I encourage you to get very familiar with your financial calculator. Now, if we were to take these numbers and plug them into our financial calculator, you would get a confusing answer. Let me show you. So here, let's just look at the equation and how it matches up to the formula, and we can see that the present value, 800, our n matches up to that n, it's 5 years. Our rate is 6%. Right now, we haven't gotten into payments, so right now payments are 0. Just go with that for a little bit, and we'll explain it better later. And we'll compute the future value. So first step is to clear everything off your financial calculator, and we're going to be using the time value of money functions, and so we need to clear out our time value of money. You may see that above the future value button is clear TVM. That's what we're going to be accessing. So push the second future value button to clear everything out. That sets your NIY, PV, payment, and FV equal to 0. So that way, in case you forget to enter something in, it's not going to give you an incorrect answer, or if you forget to put in a 0. So let's put in what we have. And remember, this is not going to get you the right answer. 800 for present value. 5 years. The payment is 0. Now your IY is 6%. Your financial calculator is nice because it assumes that it's percentage, so you put in whole number percents. So 6% in your financial calculator in your time value of money is just entered as a 6. So 6 in IY. Now I'm going to compute future value, and I get a negative $1,070.58. Obviously, this is not a negative. We aren't going to be paying money. So this is where the timeline becomes important, and noticing cash inflows and outflows. Your calculator is solving a slightly different equation than us, so we need to make sure that we recognize cash inflows and outflows when we're using our TVM solver. So the correct input, let's start over. I'm going to show you how to do it correctly, should have been a negative 800 for our present value, because that was a cash outflow. She spent that $800. She deposited it somewhere where she wasn't going to touch it. So a negative $800. So you type in your number and then you push PV and that enters it. You don't have to save it. You don't have to push enter. By simply pushing that PV button, you've already entered in the number and saved it. So you type in the number first and then push in the category where you want it to be saved. So 5 years, 5 N. The interest rate is 6%, so whole number 6, IY. Our payment is 0, so 0 payment. And we want to compute our future value, so compute future value. And this time we get a positive $1,070.58. So it gets you the same answer. It's just one was a negative and one is a positive. And it's mainly there for interpretation purposes. So cash outflows are negatives and cash inflows are positives. So the correct input was a negative 800 for present value, and that would have given us a positive $1,070.58. So once you get a bit more practiced, you'll find that the financial calculator method is much quicker and much simpler than the formula method for solving. So remember that your calculator is solving a different equation than what we did. We had said that the future value is equal to the present value times 1 plus the rate raised to the number of years. Your calculator says that future value plus present value is equal to 0. So in this equation, for it to be able to solve for 0, either future value or present value must be negative. So we need to think of it as cash inflows and outflows. Think of it as money coming into or leaving your pocket. If it's leaving your pocket, it's a negative. If it's coming into your pocket, it's a positive. So here's a picture, a graphical depiction of compounding. And I really like this picture because it shows us how quickly your money starts growing. So you see in the beginning, there's not a great deal of growth. We're having, somewhat. It's gone from $1 to $10. So, if you think about it in millions, if it had gone from 1 million to 10 million, you'd be pretty happy. But you see how quickly it starts growing here. Our money is growing very rapidly here. And that's because that interest that we deposited early on, all of these little interest payments that we've earned every year, all of them are now earning money. They're all those interest payments are earning interest payments. So all that interest that we reinvested into our portfolio, it's now earning interest, and now it's really paying off here in the future because now that money is growing at a tremendous rate. So here is what $1 invested for 24 years at different rates looks like. So if we earn 20%, we'd have roughly $80. If we had invested it at 15%, we'd have $25, $30. At 10%, it'd be about $10. At 5%, I don't know, about $5. And 0%, it wouldn't have grown at all. So you can see how that interest rate there is very important as well. Present value is the inverse of the future value. So to find present value, you use the process called discounting. We're going to discount cash flows. We're going to bring them back to today's dollars, to today's value. The discount rate, we often call that as the opportunity cost, the required return, or the cost of capital. So the present value equation, remember we said that the future value is equal to the present value times 1 plus the rate raised to the number of years. We can rearrange this equation. We can say that the present value is equal to the future value divided by 1 plus the rate to the number of years. All we did is rearrange that top equation, and now we're solving for present value. So the meanings are the same. PV is still present value. FV is future value. R is your interest rate. Also I or IY or R. Different books use different letters to mean the same thing. I teach different versions of this class, in different locations throughout the year, and several of my books use different letters. So it's just, you need to be comfortable with each of them. N is the number of periods. So let's look at an example. Remember we said present value is equal to future value divided by 1 plus the rate raised to the number of periods. Paul has the opportunity to receive $300 1 year from now. He earned 6% on his investments. What is the most he should pay for this opportunity? So if we put this on a timeline, we would see that Paul is willing to pay some amount today. We need to determine what it's worth to receive $300 in 1 year. So this 300, it should be a positive number because at the end of 1 year, he is going to have $300 to do with as he pleases. It's money going into his pocket at that point. So we need to decide what is the most that he should pay for this if he earns 6% on his investments. So you could use the equation. You could say present value is equal to future value, which is 300. Divide that by 1 plus the 6% raised to the first power because it's only 1 year. And you would get 283.02. Alternatively, you could use your financial calculator. So remember, the first step is to clear our time value of money. So second, clear TVM. And let's put in what we know. We know that our future value is 300, and that's a positive 300. Our N is 1 year. Our rate is 6%. Remember, this is a whole number 6. And remember, for now, we're just going to put in a 0 for payment. So 300 for the future value, 1 year at 6%, and no payment as of now. Compute present value. And we get a negative 283.02. And that makes sense because that's a cash outflow. He would be willing to pay up to $283.02. So again, there it's for interpretation purposes. He'd be willing to pay up to $283.02. If he paid less than $283.02 for this investment, then he would be earning more than 6%. So he would be earning a greater return than he is expected to, and he would absolutely jump on this investment opportunity. Now, if you're solving this on an exam and it asks what is the most he should pay now for this opportunity, and you typed in a negative 283.02, that's incorrect. And that's incorrect because he isn't paying a negative 283. That negative sign simply indicates a cash outflow. So by saying he would pay $283.02, that he would pay is the negative sign because it's indicating that that is a cash outflow. Let's look at another example. Pam wants to know how much she should save today so that she would have $1,700 in 8 years. Pam can earn 8% on her investments. So again, let's put this on a timeline. She doesn't know how much she should put into that account today. And whatever money she puts in there, she's going to leave it alone for 8 years. And she hopes to have $1,700 at the end of that 8th year. She earns 8% on her investments. So let's put this into our time value of money. Let's figure out our inputs. Present value, we don't know. That's what we want to solve for. Our N, that's easy. We have 8 years. Our rate, she's earning 8% on her investments. And our future value, that's the amount we want to have at some point in the future, is $1,700. And that $1,700 should be positive because that's the amount of money she's going to have at the end of $1,700 to do with as she pleases. And that payment is 0. Okay, so let's use our financial calculators to determine how much she should invest today. So let's clear our time value of money. We have 8 years at 8%. We have no payment as of yet, and 1,700 for the future value. Now remember, you don't have to push enter to save it. That equal sign means that it is saved. And let's compute our present value. And you get a negative $918.46. Again, that negative sign is simply indicating a cash outflow. So she must deposit, she must take $918.46 out of her pocket, put it into a savings account that she cannot touch for 8 years, so that she would have $1,700 in 8 years. So if we wanted to say how much should she save today, the answer would be $918.46. That negative sign is for interpretation purposes, and it's there because your calculator is solving a different equation. So in sentence form, Pam must save $918.46 today to have $1,700 in 8 years. So here's a graphical depiction of discounting, and it is the inverse of compounding. And we see the greater the interest, the faster that is going to fall. So sometimes we are interested not in finding present value or future value. We're interested in finding the answer to N, which would be the amount of time it takes for something to happen, or even IY. If I have this much money and I need this much in the future, at what interest rate must I invest it to have that amount? So we're wanting to solve for different things other than just present value or future value. Now that is completely possible in your financial calculator. And it's very simple. You do exactly what we did before, except you put something in for present value and future value, and you solve for IY. So let's just do an example here and see how long does it take for an investment to double. So this could be any number. If you want to see how long it takes 1 million to become 2 million, $1 to become $2, $2 to become $4. It doesn't matter because we're looking, it would grow at the same rate. We're just looking at how long does it take to double. So if you want me to put this in plainer English, let's say, how long will it take $100 to grow to 200 at, let's say, 10% interest? Now, obviously, the higher the interest, the less time it will take. The lower the interest, the more time it will take. So, let's put this on a timeline. Same thing we always do. Today, we are going to deposit $100. That's a negative 100. We're taking money out of our pocket, putting it into an account. So we have negative $100 cash flow. We're going to deposit this money for some period of time. We don't know how long, but when we withdraw it, it will be worth $200. So now that we have it on a timeline, it looks very similar to those problems we just worked. So now looking at the timeline, we can easily pull off our present value. It's a negative 100. Our future value is 200. Our interest rate is 10%. And our payment, we're still assuming that that's 0. So let's do this on our financial calculator. First, I'm going to clear our time value of money. Second, clear TVM. So $100 taken out of our pocket today grows to 200 at some point in the future at 10% interest. And again, we're assuming that payment is 0. So let's compute N. So this is 7.27 years. And this is years because we're assuming that this interest is compounded annually. So the interest is added to the principal once per year. We'll get into situations later where it could be months. But as for now, let's just focus on annual. So sometimes we might be interested in solving for interest rates. So if we wanted our money to double from $1 to $2 in 3 years, what interest rate would we have to earn to make it double in just 3 years? So today we're depositing $1, and in 3 years we're going to be withdrawing $2. So we know that we have $100 available for investing today, and we know that we're going to be needing twice that amount in 3 years. And we want to solve for our rate. What rate do we have to find to make that happen? So using our financial calculator, let's first clear our time value of money. We deposited $1. We're going to withdraw $2 for 3 years. And we're going to have 0 payments. So compute our IY. At 25.99% interest, we would have our money double in 3 years. So you would have to get about 26% interest.